Welcome to the fourth tutorial of this tutorial series. In this video, we will start to program the neural network of the car. I have changed the simulator. It has new features, like for example the input fields that are for changing some important variables. Also, we have a 3D view of a neural network of the car. The neural network that is currently being rendered is the car that is the camera is facing to. And also the camera now works in a better fluent way. If you want to change the car, it will do in a really fluent movement. So we have this scene that we have created in the previous video, and now in the assets, okay, here in the car, we have the car, but we want to create to create the neural network that we will in charge of the intelligence of the application. So here you need to go to create and go to C# script and call it neural network. Okay, double click in neural network. Okay, and you will have this view. In this view, you need to keep this word here and also this, because it won't use anything of Unity. We need to create some variables that will be public, the hidden layers, and I will put this to 5 for now. Also, no, here I will put one hidden layer only. Then another variable of the size of the hidden layers, and I will put this to 5. Wait. Perfect. Now some outputs that will be just for now the rotation, and the inputs that are the sticks, and they will be like 5 sticks. And now the max initial value, when we randomly create all the weights, we need to assign them a random value. So this is the max initial value that will be negative and also positive, and is, wait, this is a float, that is 1. Also, we need to create here as a private a constant that will be a Euler number, and we'll need to put here this value that is the E number. And now we need to create all the arrays that are the neurons, that is this array. This array will have the list of layers, and inside the list of neurons of this layer, of the current layer. And also we need to create a private list of float that will be, wait, the weights. Nice. So with these things, I think we finished. Also, if you want to create this is for having a new the layers of the whole network. I will put the total layers. I will put for now 0. And now here we'll need to create the constructor. We will have 2 constructors. Okay, the first will be we will need to give it the DNA we want to create. So here we need to go to the Unity and create a new third script that will be the DNA, that this is from the genetic algorithm. So the same, go here, reload, and you will have these two classes. So now here it won't give us an error. Here we have the constructor with the DNA, and here the random initialization of the neural network, depending of the generation that we are currently in. So now also we need to create a public void feed forward, that this is the update function, and we need to pass here the inputs, and it will give us an inflow out of outputs. Okay, for now put return null. Perfect. Also we need to put some getters and setters. Okay, we need to create some functions that will be doing them here. The first is for getting the list of outputs. Okay, put this, and we will need to return the neurons in position neurons dot count -1, that is the last layer. Another function that is for the activation that I have explained in the first video, that is the sigmoid function. You can also use other. We need to give a parameter of a float, and we'll need to return 1 divided by parentheses float, and here we need to put math.pow, and here we need to put the Euler number, comma, and -x. This is for the sigmoid. It will return with a float and the net value of the neural network, the output. Also, we need to create a gen random value. This will generate the random value of a neuron, and we need to return random.range, and here minus max initial value, comma, max initial value. Perfect. Also, for getting the neurons, so a new list, the list of float get neurons, and return neurons. And finally, the list of float of the weights called get weights, and return the weights. So these are all the methods that we want, but now we need to fill the neural network constructor, the two neural network constructors, and the feed forward. So we will start with the feed forward. Okay, so here we'll need to put total layers, and put here hidden layers +2, the input and the output layer. So this is because we have the hidden layers, and also the input layer and the output layer. Then we need to initialize all. Okay, so we need to initialize the weights and the neurons array. The weights equals to new list of float. Okay, these are the weights of float, a multidimensional float, and parentheses and comma. Okay, also the neurons equals to new list of float. So we have initialized the both arrays, and now we'll start to fill the neurons. Okay, so we need to do a loop here through the total layers, comma plus. Okay, so now we need to get from this I the layer weights. Okay, and this will be an float of position size. Okay, firstly, we don't have the size of the layer, but we need to create a function, okay, that will be get size layer, that will create it just, for example, here, behind feed forward, that will be get int get size layer in the position I. So the position will be layer position I, okay, and we'll need to initialize a variable that will be set to 0, and depending on the layer it will give a different size. So if the layer is equals to 0, so it is the input layer, we'll need to put here the size of the inputs. Else, if E equals to hidden layers plus 1, it will give to the size layer the value outputs, that is the last layer. And finally, if it's not of them, it will put the size layers to size hidden layers, and we will need to return the size layer. Perfect. So now we will have this function and we can continue. Here in the for, we'll need to define the layer weights and the list of flat layer equals to new list of float. Perfect. So now we need to get the size of this current layer, invoking this method with the I value of the loop, and we need to check if the I is not the output layer. Okay, and then we create the layer weights. Also in this function we will fill in the weights. So here we need to put layer weights equals to new float of the size layer now, yes, and this. And now we need to get the next size layer, saying this I plus 1, okay, because we want to assign a weight between the previous layer output neuron and the next layer. So we need to do a new loop from 0 to the size of the current layer. Okay, perfect. And we'll set that the layer weights in position G equals to new float in the position next size layer. Okay, this is because in the position next size layer we're going to put in the layer weights in position G. Okay, we want to put the weight. And now we need to do the last loop through all the next size layers. Perfect. And here we'll need to put, this is the current, we are looping to the current layer, okay, and this through the next layer. Okay, so here we need to assign finally the layer in weights in position D, position K, the gen random value. Okay, perfect. So, and finally here we need to add in the weights dot add, this is for adding a new layer weight, the layer weight. So this is the first constructor. Okay, now we need to create the neurons, okay, because this is for the weights, but here we'll need to create a new loop through the size layer, the same, but here we need to add to the layer of the neurons, that this is the layer, we need to add the zero value. So initialize the neurons also, and also add to this array the layer. And now we have finished the first constructor. Now we'll copy this, okay, to the second constructor, but we will change some things. Okay. So the most parts are the same, but however we will change this later, because we will first do the feed forward, that is most important. Okay, so in the feed forward we have the inputs. Yes, the inputs, that is, they are here. Okay, and now we need to start updating the network. So we need to go to get the weights layer. Okay, the input layer we need to assign to the input layer, that is the input layer is the layer that is in position 0. Okay, so we'll need to set the inputs in input layer first. So we'll loop through the inputs length and put the input layer in position I in the inputs in position I. Perfect. Now we'll need to update the weights. Now we'll need to update the neurons from the input layer to the output layer and get the output layer values of the neurons. So we'll first start with an int that will be layer. The layer must be less than the count of the layers, and t plus plus, sorry, wait, layer. sorry. Perfect. Okay, so we'll continue. Now we need to do the same as with the constructor. We need to get the weights in layer equals to weights in position layer. Perfect. Get the next layer, that is layer +1, and create the list that will be neurons layer, and it will be the neurons in position layer, and also the list of flat of the neurons next layer. That will be neurons in the position next layer. This is simple for now, but now we need to do another loop, okay, through the neurons next layer dot count. Perfect. This neurons next layer will be from the next layer, is important. Okay, and here we need to create the sum that I have explained in the first video. We need to add all the multiplications of the weight with the neuron and sum all. Do the sum of all of them. So we'll need to create this variable. I have created just now, and get the neurons of the layer known as layer dot count dot game plus plus. And now we need to do the multiplication. We will need to get the weights in the layer in position j, okay, that is the current layer, and I, that is the next layer, and multiply this with the neurons of the layer in position j. Perfect. So this is the feed forward multiplication, and we'll need to add, okay, this to the sum, and then we'll need to assign here the neurons next layer in position I equals to the sigmoid, that is the activation function of the sum. Okay, this is important. We need to do the sigmoid that we have created here for having a value between 0 and 1. And then I think that almost all is done. Yes, all the things are finished, but now here we don't need to return anything because we have assigned all the values. Okay, so we'll put here void, and we'll get the values from the get outputs function that we have created. So the video is finished. We have created all the neural network. Okay, the last thing we need to do is with the DNA create the new constructor and assign the weights, but this is simple, and we do the most complex thing, that is the feed forward and assignment of values. So hope you like the video and you have created this neural network.